Thank you. So, okay, let's start. First of all, thank you all for your time, for being here and listen to us. We will store you a lot of time, just a little bit of an hour. So let's start with a little bit of introduction. I'm Matteo Beccaro. I'm founder and CTO at Opposing Force, which is a small company in Italy which focuses on physical security, so hardware, building, and cities. These are my Twitter handles if you want. Keep in touch, have questions, feedback from the presentation, or whatever.
I am Matteo Collura, and just got a Bachelor of Science last month, and so I'm still a student. And I applied for a masterclass in nanotechnologies for ICT in Italy. Well, it's an international program of study. And my Twitter as well is displayed on the screen, so if you want to follow me, I will appreciate. So now we will start speaking about our research, and I will hand the word to my friend.
Okay, so before starting with the talk, I want just to introduce you this organization. We joined this organization in May, and it's about securing smartcities.org. What the organization purpose is to provide documentation for cities, decision makers, and vendors about what could be the issue if they not properly implement security. So the organization is, as I said before, no profit, and everyone can join it and help with the provided documentation, write new documentation, or try to put in contact with the proper people, like vendors, etc. So that's our agenda for today. We will start with a little bit of introduction about what is a smart city, what are the components of a smart cities, and etc. And then we focus on transportation system. We will provide free case studies of a sample city in Italy. And the purpose of this talk is to provide a method to assess smart cities in general. And we will apply this method on our case study. So let's start with what is a smart city. What is a smart city? Smart city is composed by several elements. As you can see, we can have the smart waste management, transportation system, water management, surveillance, energy management, smart metering, etc. Our talk today will be focused on smart transportation system. Sorry, I drink a lot.
Water.
Okay, yeah, mostly. Let's say that. Smart transportation system. What is a smart transportation system? Every element of a city, we try to divide it in smaller elements, and also smart transportation system can be divided in several elements. We have smart traffic control, we have smart parking, street light, public transportation, etc. And each element communicates with each other in different ways. In our experience, we found mostly two systems. The first one is when we have each element of the system which communicate with its own control system. For example, let me see if I can. Here you have traffic control system, like for example sensor would detect traffic from the cars, or if the cars are in a jam or whatever, that communicate with its own smart traffic control system. Then the smart traffic control system communicate with a central backend, which is this one. And the same applies for every other system, for example, lighting control, different kind of system for parking, etc. And then the central system communicate information to the citizen, because at the end, the point of having a smart city is to provide better information to the citizen, is to provide smarter information, so how to avoid traffic, for example, and to how reduce cost. So the other system is similar. So also here we have control system for each element of the smart city, but these elements communicate directly to the citizen and directly to each other. Sorry? No, okay. And again, the citizen is at the center of it, at least when we speak about transportation system. Let's go more in detail. A smart transportation system is composed by mostly three sectors: the private transportation sector, the public transportation sector, and the shared transportation sector. The last one is the newest. We have bike sharing, car sharing, etc. On our talk today, we will focus on bike sharing. And for each system, we have to divide again and find this schema. This schema provides a method to test the device itself. So we have physical data from the world outside, which are detected and parsed, let's say, from the sensor, then sent back to the cloud domain. The cloud domain is like the brain of our system, which analyzes the data received from the sensor and can provide information to the client domain and send commands, actions to the other edge domains. For example, if the traffic sensor detects a lot of traffic, they can modify the behavior of the lighting system. That's why before we said that each system must communicate with each other. So we try to apply this schema for our systems and try to see where are the weak points of it. Okay, let's start with the first case study. This is all of these three case studies are real-world examples, so they are found in the wild in a city in Italy. I won't make any names during the recorded presentation. There is a Q&A session after that. So the parking meter device itself is a small device you can buy at any shops, and you can actually put credit on the device, recharge the device in two different ways. The first one, you can recharge it online. So you just connect the device itself to your computer, go to the website of the vendor and select the amount you want to recharge the device. Or you can go to some shops, which are mostly tobacco shops or supermarket, and bring the device to the merchant, and the merchant itself will recharge your device. So you have two different ways. And once you have credit on your device, you can turn it on, put it in your card, and select the city you want to pay the parking, because the device itself is available in 40 different cities in Italy at the moment and growing. And once you have selected the city and the correct fee for your place, it automatically decreases your credit over time. So every minute it starts removing credits. And the inspector, for check if you are paying correctly or not, has two different ways. The first one is through a, let's call it, online database, in which you can, from the device itself, you can read the serial number. The inspector can check if the serial number has credit or not, if the device associated to the serial number has credit or not, or through the display, which is the most common use. Through the display means that the device itself shows different information on the display. For example, it shows your fare zone, it shows when you started the payment, it shows the fare you are paying, etc. And the inspector can check if the information matches to the place you are. So we started our analysis with extracting the firmware, because there were several debug interfaces we will see later. And from the firmware analysis, we found there were no integrity checks, no encryption or obfuscation, and the firmware again can be easily extracted both from the device and from the backend during an OTA update. So extracting the firmware, we could modify the firmware and re-upload the firmware on the device. And that means we can, like, for example, avoid the payment part and just display the correct information to the inspector. As I said before, there were several debug interfaces left open by the developer. So I don't know if you can read, but there were a JTAG port SWD port we used for extracting firmware and modify the behavior of the device and try to understand more important information I'll show you later. Another thing we tried to understand was the communication part. So this is, with the information retrieved from the firmware and from the debug interface, we modified our schema of before in this way. So we have the edge domain with the parking device which communicates through USB to the cloud domain. The cloud domain is used for, like I said before, remote recharge, generate invoice, updates, etc. And the cloud domain communicates via GSM to the client inspector application. And the client inspector application can also communicate with the parking device through NFC. There is an NFC interface which at the moment is not very used. The problems we found during the communication analysis was that there is no data validation between the edge device and the cloud domain and the cloud appliance. And the inspector has all the trust in the edge device provided information. So if the edge device can provide the correct information, the inspector is okay with that. There is no other checks he will make. So since there is no integrity checks, no encryption, and no authenticity checks, we could actually forge fake information sent from and to the device by the cloud appliance. And using the before information from the firmware and from the debug interface, we found what was the formula for calculating the correct fee to pay. So that's the formula. And as I said before, some of the information displayed on the device are actually present in this formula. And those information are the price per time unit and the seconds you have elapsed from when you start the payment. Some information are usually set to 0, which is the minimum fee. That's the minimum amount you have to pay for just starting the parking there. But there is one information which is usually not displayed, which is the fare frequency. The fare frequency is the frequency for which you have to pay the price per time unit. So for example, if there is 1 hour, the fare frequency is 1. If you have to pay the price per time unit each half an hour, the fare frequency will be 2, etc. So this information is not displayed, and as you can see, this is a multiplication. So if we set the fare frequency to 0, and we can do that because we can forge data from the back end to the device itself, and this data is also composed by configuration files, so we can just modify any of this data as we want. We can set fare frequency to 0, and then our whole formula becomes 0. So that's what we call our Saint Graal for the device itself. It's a very easy hack to do. Actually, you can write a small appliance for that and modify the device in a couple of seconds, and then you can like resell it or do whatever you want. You won't pay any parking fee for 40 cities in Italy. Some of them are major cities. An interesting thing we found out later, and during the process of disclosure, the city has published a document which inform for how many money they make from parking system, and it was like $26 million. So you can understand there may be a market for hacked device like this. And that's just one city of the 40s in which the device is available. So I probably leave the word now to my colleague for the other 2 case studies, the bike sharing one and the public transportation one. Thank you.
Okay. Sorry. Okay, thank you. So let's move on with the bike sharing and as regards the shared transportation systems. So basically, we can divide our analysis, we focus our analysis on bike sharing, dividing into 3 steps. The first step involves the unlocking of the bike from its own station. The second one, well, you ride the bike, so it's not so interesting from the point of view of security. And the third step is when you unlock again the bike in the station. So let's start from the first one, as we said. And as you can see from that picture, there are essentially two ways to unlock a bike from the station. So using an NFC card, and the other one is using a mobile application from the company that provides this service. So here is the station, and as you can see on the top, there is the NFC reader, and so there you can pass your card and unlock the bike, if your card is enabled, of course. And as regards the mobile application, it needs a GPS position, because you need to be close to the station, and then you can select the number of the station to unlock the bike. But let's start our analysis from the mobile application. So first of all, we tried to decompile it, and something messy came out, because code was not obfuscated, and moreover, there were the vendor credential, the administration credential were hard-coded inside. So that's quite a pain, I mean, because if you try to log with those credentials, well, essentially you can do whatever you want. You can create new users, charge credit on them, unlock bikes.
Get credit card information of the user.
Yeah, we don't say that. And moreover, some SQL injections were found then, but we did not exploit them because
it's illegal.
Yes, we cannot go further. So we can leave you, well, we can let you imagine what is inside those systems. Let's move to the NFC part now. And okay, it's my fair ultralight card. Essentially, all the data sectors are empty. And OTP is empty too. So let's try to imagine what is the only sensitive information inside a Mi-Fair ultralight card. And have a look inside this rectangle. And please raise your hand if you have the idea of what is inside this rectangle. No one got it? Okay. Well, it is the UID, and just printed in reversed way. So they ease you the process of finding the UID. But what's the problem of this? Being this the only information, the only sensitive information needed to unlock a bike, if someone can get close to that card and can scan it, you can just easily clone to a Mi-Fair clone, and so you steal someone else's card. And, well, it is not so a good thing, because if you can get cards of every people in a room, for example, I don't know, you pass close to one person and you scan his wallet with your mobile phone, and you can steal those kind of information and take bikes.
For example, at university.
Yeah, at university is very easy.
Everyone has one of those cards. Universities are crowded, so no one notices if you start scanning everyone. You get like 10 of these cards.
It's a very hard issue. And okay, as regards the secondary steps, we found some physical issues, because from the point of view of the station, in order to find out if the bike has been unlocked correctly, there is a sensor on the hook. And if you try to slightly move the bike from the station, but just a little bit, after 30 seconds, the unlocking process goes timeout. But since the station believes the bike is still inserted, when it locks, it doesn't actually lock the bike. So you can easily extract it, and the station believes it is still inside. And that's a problem, because you can unlock the bike, and well, steal it. The problem is that a posteriori, after that, if you leave the bike to another station, of course, the system will detect the same bike in two different stations. So it will be a problem, and the system will recognize the error. And another problem is that if someone else leaves his own bike inside the station where you stole the other bike, the system will detect two bikes in the same station. So it will get an error. But the point is that the problem a priori is not fixed. And so you can, if you steal a card of someone else and you go stealing bikes, the point is that the company will go looking for not you, but the guy you stole the card. So it is another important issue.
We found one of those bikes 500 kilometers away from the city.
And
I don't know how.
Yeah, who brought the bike?
500 kilometers.
Okay, so those are the main issues about the bike sharing. So let's move to the public transportation systems. And as regards this research, we divided into two main architectures. The first one is we called offline system, because we will see later. And the second one, online systems. This difference regards essentially the way the devices are communicating with a backend, and we will see now. So let's start from the offline system. In this kind of system, we have ourselves with our tag, NFC card, and we can essentially get on the main transportation vehicles, so buses, metro, trams. And those devices are connected to a main cloud. And this cloud is connected to a blacklist of UIDs, because when you run out the rides on your ticket must be blacklisted. But this communication is just one way. So the cloud is communicating in some way, maybe a certain time with the blacklist, but there is no live check from the blacklist to the vehicles. And for this architecture, we found out two main vulnerabilities. The first one we call the lock attack, and essentially it involves a nice exploit about making read-only a page on your ticket. And this page is the page where you store the rides left on your ticket. So if you are locking the correct bit on a MiFerry ultralight ticket, you can make read-only the page where the rides are stored. So essentially, you make your multiple ride ticket unlimited for life. And it is easy to be fixed. Just need to let's say, to check if those bits have been locked. And but this kind of check is not so implemented. Well, in our city they implemented this check, so this is not valid anymore. But after
our disclosure, and no acknowledgement.
Not they didn't even say thank you. So let's move to the next one. Okay, this is nicer, I think. Time attack, because if you find the place where the timestamp of your stamp ticket is stored, and if you manage to reverse how it is encoded, I mean, if you find the time of start for the timestamp to be evaluated, you can forge your own data timestamp, and you can write on that pages, making your ticket as if it was already stamped. And so you don't even remove any ride, because you get a ticket which is already valid, because you wrote the date and the time in the correct way. And so this is quite nice, I think. And same...
no thank
you. No thank you. Yeah, same story for this other vulnerability. After disclosure they fixed, but no thank you. Okay. Okay, as regards the other architecture, which is the online system, okay, in this case, we have not a unilateral channel of communication from the cloud to the UID blacklist, but this blacklist can also interact with the vehicles live. So, how to bypass this problem? So, a direct communication between the blacklist and the vehicles. Well, if you try to exploit the reply attack, essentially you can clone your ticket, your ready to be stamped ticket. You clone on clone tag, or you can even use an emulator like the Hydra, and you emulate your ticket to be stamped. Then you can stamp it, and you reply back to the original ticket to have a ready and perfectly clean ticket to be used. And this is very difficult to be fixed, because even if you have a UID blacklist, if you try to forge a new UID and you put inside the network, since there is no whitelist, and a whitelist is very difficult to be implemented, because just think about if you go buying a new ticket, that new ticket must be usable immediately, because it's new, I already bought, and I want to have the possibility to use it immediately. So a whitelist must be very well managed to be implemented. And this is not our case. So if you forge new UIDs, they can be easily injected in the network, and you can easily forge new tickets. And this is a very big issue and difficult to be fixed.
We found those issues were found in like most of the city in Italy, but after we present those vulnerabilities, a lot of people from abroad,
other
like
cities,
other cities, start bringing us the new tickets from their own transportation system in their city.
So
and
if
we
you
found,
have some,
if you have some,
if you have
from
some to
Singapore,
to share,
nice to see them. And we found the same vulnerabilities in cities like Moscow, in cities like in some place in Vietnam, US.
He told from Amsterdam too.
Amsterdam was vulnerable about that, and they changed something like putting some other data on the OTP to fix some of these issues. But I think the reply attack still works there.
Yeah, it's the hardest to be fixed.
Yeah, South America, etc. So it's an interesting case study to check.
And
your city.
So, what's next about our research? We just covered the smart transportation part, but there are still a lot of environments to be checked. And so maybe the next one could be smart city surveillance, because nowadays a lot of cameras that are used to, for example, check the traffic, but in the sense of limited traffic areas, limited traffic zones. Don't know if you have here in Singapore, maybe there are some roads you cannot ride in, provided you have maybe a special permission, and those kind of cameras will detect your plate and send you a fine if you get in. And maybe it would be nice to study how that mechanism works. So maybe you can intercept those data.
Yeah, we're also working on some cameras for access control, in which the cameras are connected to some central system for the cities, and for like government buildings, they check up the plate to see if your car is registered to that specific department of the government. If so, they open your gate automatically, and you can go in and out. And
maybe they check also your face and face recognition, those kind of things. And okay, as regards water management, come to think about what happens if each one of us has a monitored amount of water to use for its own purpose, or being, let's say, water disposal for people, and if we can manage to know how it works, those kind of information are shared in I don't know which ways. Maybe there will be some networks, and we can find if the communication is secure.
Yeah, the problems here is that we can see in two different ways from a money perspective. So try to avoid payment of water, or the second perspective is more like let's think about an attacker point of view, in which you can like close the water for so I don't know, a neighborhood of a city or stuff like this. And we are trying to understand where the cities are more worried about, if about the payment part probably, or about the blockage of the service, blockage of the service, the denial of service of water management, probably also there, but that's an interesting point of view.
Then the smart city lighting system. This is maybe regards the management also of traffic, because if you have a road which is mostly there are a lot of cars, even during, well, of course, maybe during late night, it is better to keep the lights on. But maybe if you have a smaller road with not so many cars, that could be a nice way to switch off the lights and save some money from the city point of view. But think about an attacker from an attacker point of view. If you can, I don't know, switch off all the lights, would be a pain. I mean,
what we saw here is that not only roads are using smart lighting system, but also public buildings. So the point here is not such that you can turn off the lights of a road, but you can turn off the lights of buildings, also critical ones, like, for example, let's think about hospitals, let's think about government buildings for critical infrastructures.
Conference rooms.
Or, I know, let's think about prisons.
Yeah.
That's another example, an interesting example in which we are trying to get some city awareness.
Yes, and directly connected to this is the smart traffic light system. So just try to imagine what will happen if you if you force the green light into all the streets here in the nearbys. Will be a lot of crashes, and we don't want to.
There is a paper about that, about research made from some guys of the organization
Securing Smart Cities.
I talked to you before, in which they analyzed the traffic sensors, and those sensors are used to indirectly control the traffic light system. So they found out that they could like forge communication between the sensor and the main system that control the sensor and communicates with the light system. So controlling the data from the sensor to the control system, they could also force the traffic light as they want. So they could like turn that green, if they want to pass, just turn on the traffic light green on their way and such things. So
it could be very dangerous if an attacker can put hands on it, well, a malicious one. And the last point is, what if we can hack a whole city? And this is the last point we leave you, and it's just to end our talk.
Before ending the talk, I would like to understand if there is some of you with experience about smart city security, and if they have any. The point is, we had a panel actually in Vegas last month about how can we create more awareness around smart city security. How can we force, let's say, decision makers to understand the problems and to act properly. And during the talk, the problem was that all the people in the panel was a security researcher, or anyway, technical people. So everyone said, yes, that's a problem, we need to create awareness. And the other guy, yes, that's a problem, we need to create awareness. But
there was no communication with
no one
executives.
No one was a decision maker, or someone from the government, someone from the some vendors of smart cities devices. So we decide to ask during our conferences. We had a similar speech at DEF CON last month. If there is someone from the audience who has some idea or some connection to the government, to vendors, to who makes decision in the end, and won't share their thoughts or ideas or whatever.
We have to build this channel of communication between
please,
technical and executive.
Also, if you are technical, have some like brilliant idea how to fix everything.
Yeah, so if there is someone here or a friend of a friend of a friend, please
raise your hand. No one.
Okay. So if you have any question, just raise your hand.
We are like 20 minutes, so you can go outside. You can go to have lunch. So ask questions.
No questions? Don't be shy.
We can stare each other for 20 minutes if you prefer. It's up to you. I'm not kidding. I won't move for 23 minutes.
No questions?
No questions? Okay, thank you.
Thank you.
Thank you.
We're going for lunch now.